Hi, this is Paul again, and I've got a new video to show you, and this I'm calling Quad Step Phyllotaxis 3D Order Lesson 7. In Lesson 5, I showed that an integrated system of polyhedra that was based around the vertices of an octahedron would produce segments starting from 4 going up to 32. And these segments would line up to colored balls, 32 colored balls in a ring, and these balls could be put in a sequence of colors of red, yellow, purple and cyan. And what's amazing is that these 32 ball rings could be the basics for the geometry of a pine cone. And I called this system Quad Step Phyllotaxis. Okay, I moved on to lesson 6 and I focused on the 5 segment geometry. And you can see that the latitude rings of 40 colored balls of quad step phyllotaxis lined up perfectly to the vertices of all 3 polyhedra that I show. Now this is an amazing find to do something like that, and it should never be snubbed just because it contradicts the chaos theory. Okay, we've showed the 5-fold stuff and we showed the 4-fold stuff. So let's take a look at the 6-fold stuff. Now the 6-fold segments are based around the vertical center axis between the vertices of the dodeca. So the dodeca is the boss when it comes to 6-fold geometry. Now I show 48 ball rings for the dodeca. I was having second thoughts about 48. Should it be smaller than that? So let's check on 24. We'll start with 2 little white dots. And now we'll give it a polar array of 24. And you can see that the 48 ball is better because it picks up all the vertices. So it's better to check and make sure. Okay, now I'm going to give latitude 48 ball rings to the 3 polyhedra. And I'm also going to give 3 orbital rings, yellow orbital rings that will make 6 segments. I'll move the 3 polyhedra together again, and you can see this system works as an integrated 3 system. Okay, now I'll show you this in the top view. And then I'll move the 3 polyhedra apart again. Now if you study this geometry, you'll see that the 48 balls are lining up perfectly to vertices and the geometry in perfect symmetry. Okay, I'm taking you back to the front view again, and I'm going to hide the dodeca and just show the outlines and show 2 cubes. Now the red and the yellow cube are rotated opposite to each other at 75.4 degrees, and the other direction is 44.6 degrees, making up 120 degrees. Now I show a red A and a red B on the edge of the 2 cubes, and they are perfectly golden ratio. 48 balls are lining up to these offset vertices of a golden ratio, so something is correct about this 48 ball array. Now we'll spin this stuff around and you can see it better. Now this quad step phyllotaxis have given us the geometry of the strawberry, the pineapple and the pine cone. And these 3 types of latitude rings line up to give us 4-fold, 5-fold and 6-fold geometry with no problems whatsoever. I am sure if some scholars took an interest in this excellent find, I think we could get a little bit closer to understanding the spherical geometry of diseases in 3 dimension, because I don't think you can do it with 2-dimensional chaos mathematics. Anyways, to the few people that think order is better than chaos, this is Paul saying thank you very much for watching my video.